welcome to design.
Good afternoon, my dear professor.
We're Team 9. I'm Han Hongzhi.
I'm Huang Xingyuan.
Today our topic is Grade 2 School. And this is our content. This is a 3D modeling for our structure. And here's the front view of our design. Here's the details and I'll talk about it later. First is our project background. Extreme weather is becoming a greater threat to human survival, while energy shortages and environmental pollution are becoming a more serious problems. Climate change is now a global concern, drawing increasing attention worldwide. As awareness of environmental protection and sustainable development continues to grow, traditional residential buildings face many challenges in energy consumption and environmental impact. Therefore, improvements are urgently needed. Next is our design concept. We think a modern school building should focus on innovation, sustainability, and how to create a learning environment that meets contemporary needs. Our design aims to establish a green energy schools that fulfills high performance schools. Also, our goal is to reduce the environmental impact, optimizing energy use, creating a healthy learning environment, and promoting a connection with nature. By combining these four features, our design aims to establish high-performance smart systems that serves as a future urban development. Next is our key design features. First of all is our grid shape structure. This structure can provide an excellent wind and earthquake resistance, which means in earthquake area, it can reduce the reinforcement and lower the maintenance costs, and also modular design. Our structure can simplify the construction process, making it more efficient. And next is our natural ventilation and lighting. The open courtyard and well-planned layout allows for better airflow and also sunlight exposure, which means it can reduce the lighting energy during the day, also reduce the air conditioning use. Also, it can improve the energy efficiency. It reduces the electricity bills in the long run. Also, the last is we can lower the maintenance costs. It can reduce the damage risk and reparation costs. By combining these four features, our schools can not only benefit for students, but also our community and environment.
Next, building materials. These materials used in this design include bio bricks, which require low energy to produce, and can replace traditional bio bricks. For interior decoration, line fiber boards are widely used. They are lightweight, provide insulation, and absorb carbon dioxide, and also have potential for negative carbon emissions. These materials can naturally decompose without harming the environment. Additionally, they are eco-friendly, non-toxic, and recyclable. Then, energy utilization. The solar power system will be installed in walking plaza, providing energy for the entire building's light system. This maximizes energy efficiency and can reduce the reliance on traditional power sources. Then, wind generation. The wind turbine directly supplies the electricity for the buildings, and it is flexible. It can be installed on country yard, rooftop, or independent structure. Then, structural design. We design a recycling area to collect all the materials, and these materials will be sent to recyclable companies or reused within schools, such as turning the waste paper into a notebook. Then, food waste system. The food waste system that converts organic waste into compost. And these organic waste can also be processed into biogas, which can also be the power for the buildings. The center space of the grid-shaped school will be set up for rainwater collection and grey water harvesting. And this is our filter. First, I will introduce rainwater harvesting. Tanks are placed on rooftop and different floors, which can collect rainwater through the drainage pipe. Sunken areas are set up in gardens or lawns to allow rainwater to soak into the ground. It can replenish groundwater. Then, grey water recycling system. The grey recycling water system can reduce 30 to 50% water consumption. The most special system of our structure is HVAC system. H means heating, ventilation, and air conditioning. A smart temperature control system will automatically adjust indoor temperatures to ensure a comfortable learning environment. Then, eco-friendly and greening. Our grid-shaped school service has much larger than traditional buildings. So, we design green walls with ferns and climbing plants, turning buildings' exterior into vertical forests. And the vertical forests have four advantages: absorb carbon dioxide, reduce urban heat island effect, increasing the greening of the living environment, and providing nature shading in summer. This lowers the demand for the air conditioning.
Next is our advantages. Okay, we should have a budget overview, but I don't know why the pages is being eaten by, technology. Okay, here is our land use efficiency. In modern architecture, increasing land use efficiency is often achieved by raising the building's height or just increasing the floor area ratio. While this method is convenient, but it actually increases the construction costs and also wasting the actual usable space. Our structure, as you can see, is a grid-shaped structure. It has the interior space is more flexible and functional. Also, because its adaptability, this structure is stronger and more durable. Also, it allows for a higher density in limited spaces. By maximizing the land use efficiency, this structure can provide a practical and sustainable solution for rural architecture and modern urban. Next is our modularization. Modern buildings is still using the traditional construction methods, which takes a lot of time to complete and also easily affected by labor shortages and bad weather. Additionally, the high housing prices make it difficult for people to afford homes. Our advantage, one of the modularization, is shortening construction time. Because our buildings is pre-made, which means it allows for a quicker installation. Second is we can reduce the labor costs. We can reduce about 50 to 70% costs in comparison with traditional buildings. And last, we can lower the material costs. This is not only because our modularization, but also because we've chosen the materials like biobricks and fiberboards, which can be decomposed by nature. So we don't have to worry about the recycling costs. is our future expandability. This school will not only suitable for schools, but also can be integrated into urban planning. And it can coordinate with transportation system, green spaces, even in parks. It enhances its adaptability, expandability, and also increasing its long-term sustainability. A point of this page is, first of all, the grid-shaped structures allows for easy expansion by we can stack the modules easily. And also, future expansion are pre-planned, which means we can add the additional section without affecting the existing structures. The second point is our flexible interior layouts. Some parts of our buildings, like walls, are resilient, which means it allows the buildings to adapt to different needs. By combining these features, our structure can provide a sustainable and future-proof solution for the schools and urban environments.
This is the end of our presentation.
Thank you for your attention.
Questions from our judges? I feel the judges are out of their battery.
Yes, I think this is a great idea, and I like your grid system. I think it does increase the water variability.
Yeah.
And that's very good idea.
Thank you.
However, okay, I have a little question
Okay.
about this grid system of construction.
Yes.
You have a lot of cantilevers,
Yes.
and cantilevers means it would how should I put it? I think you would need actually more material to make it strong enough.
Oh.
Structurally.
Okay, I got
And
it.
you were talking about you would use less material. However, with this structure, you need more material to make it strong. Have you thought about that?
We have said it about is we can reduce the material cost, it's not reduce the materials.
Okay.
Yes.
But the structure,
Yes.
because the structure part of the cost is actually the main cost of a building, especially a public building. Does that strong enough? Have you thought about that?
Okay, thank you for your question. Actually, we have some successful cases in this world, in the globe. For the first example is the Brooklyn, New York 2B Tower. It is the highest design in modular design. It had about 32 stories. And also in Taipei, we have the National Taiwan University Hospital. It is also modular and it is successful. Yes, you know, I know. Okay. Thank you. Any questions?
Any other questions for our judges? No? No? Thank you very much.
Thank you very much.